Hello everyone. So friends, in our previous lecture we discussed about the bubble sort algorithm. So in this lecture we will discuss about the insertion sort algorithm. So let's discuss this algorithm in detail. So here if you see, insertion sort is a simple sorting algorithm that works the way we sort playing cards in our hands. So when we play with the deck of cards, usually most of the games are involved where we keep few cards in our hand, and what we generally do is we keep them in proper order. So how do we manage to keep them in proper order is we use the insertion sort algorithm. So let's say we have this deck of cards which is lying in front of us, and let's say we pick few random cards from the top of the deck. So usually what we do is when we pick up the first card, we simply keep it in our hand because it is already sorted. And when we pick the second card, the card which we have picked, we simply compare it with the card which we have in our hand. And based on the comparison, we either keep that card before or after the first card. The deck of cards which is lying in front of us are basically in random order, or you can say they are basically unsorted form. And the cards which we have in our hand are basically kept in sorted form. So when we pick up the third card from the random cards, now the card which we have picked, we simply compare it with the cards which we have in our hand. So we compare the third card with second and then with the first card. And based on the order which we are following, we simply place the third card either after the second card or in between first and second card or just before the first card. So similarly, let's say we have this unsorted array. So using the insertion sort algorithm, we divide the given array into two parts. One is the sorted part and the other is unsorted part. So how the algorithm works is, from the unsorted part, we take the first element and place at its correct position in the sorted array. So here we are simply picking one element from the unsorted array, and based on some logic we are simply putting that element into the sorted array at its correct position. So this is done by shifting all the elements which are larger than the first element by one position. So here let's say we are sorting the array in ascending order. So the first element which we pick from the unsorted part, we simply compare the element with each and every element in the sorted array. And all the elements which are larger than the first element, we simply shift them by one position. And as soon as we encounter any element which is smaller than the first element, we simply store this first element just after that. And this process is repeated till unsorted array is not empty. So friends, let's see the demonstration of insertion sort algorithm with an example. We'll take an unsorted array. We apply the algorithm mentioned here and we'll see that how we can sort the array. So friends, here you can see that we have this array from index 0 to 5. So basically there are 6 elements with the value as 3, 1, 5, 2, 6, 4. Now let's say we want to sort this array in ascending order. So how do we start this algorithm is, we simply pick the first element. So here it is 3. And as we have picked the element 3, we know that there is only one element, so it's already sorted. So basically this algorithm starts from the second element because the first element is already sorted. So friends, in our previous slide we discussed that we divide the array in two parts. One is the sorted part and other is the unsorted part. So when we start our algorithm from the second element, so the elements to the left are basically sorted and the elements to the right are basically unsorted. So now what we do is, from the unsorted part, we simply pick the first element which is 1. And what do? Is we simply store this element, let's say, to a temporary variable. So as soon as we store this element to a temporary variable, what do? Is we simply provide a hole here that this part is empty. So after providing this empty space, what do? Is we simply compare 1 with the element in the sorted array. Now as we are sorting this array in ascending order, we simply compare that whether 1 is less than 3 or not. So here 1 is less than 3. So therefore 1 should come before 3. Here you can see there is no space. So what do? Is, as we discussed in our previous slide, we simply shift the elements which are larger than 1 by 1 position. So here we'll simply shift 3 to this empty space. So after we perform this shift, that are there any other elements in the sorted array or not? So here you can see there was only one element 3. There are no other elements. So we simply place 1 at its correct position. So after placing 1 at its correct position, you can see that now our sorted array has 2 elements, 1 and 3, in sorted form. So now we simply pick the first element from the unsorted array. So we simply pick 5. We store it into a temporary variable and we create an empty space here. Now what do? Is we compare 5 with 3 and we know that 3 is smaller than 5. Therefore 5 has to be placed after 3, which is this spot only. So there is no shift because the element to which we are comparing in the sorted array is already small from the element which we picked from the unsorted array. So the position of 5 will not change. 5 will be stored at its own position. And here you can see that as 3 was less than 5, we didn't compare 1 with 5 because as this is a sorted array, 1 will be by default smaller than 5. So after placing 5 at index 2, now our sorted array has 3 elements, 1, 3, 5, and from the unsorted array we simply pick the first element, which is 2. We store this 2 into a temporary variable and we create an empty space here. Now what we do is we compare 2 with 5. So 2 is less than 5. So we know that 2 must be lying somewhere before 5. But here you can see in sorted array there is no space left. So what do? Is we simply shift the larger element by 1 position. And as here is the empty space, we can simply shift it here. So 5 comes here and the empty space comes here. So friends, here we are not sure that whether this is the correct position of 2 or not. So what do? Is we simply compare 2 with this element, which is 3. So here you can see 3 is also greater than 2. So we know that 2 must be lying somewhere before 3. So what do? Is we simply shift 3 by a position. And as here is an empty space, 3 comes here and the empty space goes here. So friend, we are still not sure whether 2 must be placed here or not. So we simply compare 2 with 1. And here you can see that 1 is smaller than 2. So therefore we are sure that 2 must be lying after 1. And the position after 1 is empty. So we simply store 2 at this empty position. So friends, after this step, Now we have 4 sorted elements and 2 unsorted elements. So we simply pick the first element from the unsorted part, which is 6. We store 6 into a temporary variable. We create an empty space here and we compare 6 with 5. So as 6 is greater than 5, we know that it must be lying after 5. So after 5 we have this empty space. So 6 will be stored at its own position. So now our sorted part has 5 elements 1, 2, 3, 5 and 6 which are sorted, and in our unsorted part we have now only one element left. So we simply pick the first element, which is 4. We store it into a temporary variable and we create an empty space here. Now we compare 4 with 6. So 4 is smaller than 6. So it must be lying before 6. But there is no space left here. So we simply shift 6 by 1 position here. So 6 comes here and we have empty spot here. So now we are not sure whether we simply put 4 here or not. So we simply compare 4 with the element just before the empty spot, which is 5. So that we are sure that whether 4 can be placed here or not. So as 5 is greater than 4, therefore we know that 4 must be lying before this element. But here there is no space, so we simply shift 5 by 1 position to this empty spot. And the empty spot reaches here. Now we are still not sure whether we need to place 4 here or not. So we simply compare 4 with 3. Now as 4 is greater than 3, we know that it must be lying after 3. And here you can see after 3 we have this empty space. So we simply store 4 to this empty space. So when after this step you can see the complete array is sorted. So here we saw the insertion sort technique, where we divided the array into 2 parts. One was the sorted part and other was the unsorted part. And with each step we simply picked the first element of the unsorted part and we simply placed it into its correct position in the sorted part. And this we did till the complete array was sorted. So friend, in this lecture we saw the basic demonstration of insertion sort technique. In our next lecture we'll see the working of the code step by step using an animation. I hope you like this video. Thanks, have a nice day.